Lesson 3-4 overview, where we're dividing polynomials using two methods, long division and synthetic division. So the first method here, dividing using long division, goes something like this. If you take this first term out in front, and you are looking at this x in this case, and the first in the quotient here, and you, I'm sorry, the dividend and divisor. And so the x times what is x cubed? You would hopefully say x squared. In other words, x squared times this x gives me this x cubed. Then you also distribute that x squared onto this 3. So x squared times that 3 is 3x squared, and I line it up under its like term. And then so far I've created this much. I need what's up above. So I'm going to take it away, subtract, and see how much I still am left with that I need. So in this case, the x cubes, and it should always eliminate this first item. I needed 5, I created 3, so I still need 2x squared more. And then I still need all the rest of this that's from the original problem. And then I start again. So let me take these lines out of here that I did that time and switch over now. Now we're looking at this 5x squared with this x. So x times what am I going to put up here to make 5x squared? And hopefully you would say 5x. That's not what I want to do. Oh my goodness, what am I doing? This x and this 2x squared. I don't need the 5x squared anymore. I already made 3x squareds. I need 2x squareds. So x times what will make the 2x squared? And hopefully you say 2x. And then 2x times this x, 2x squared. I needed 2x squared. I've made 2x squared more now. And this 2x times this 3 for a 6x. So I still needed what was in blue. By adding this 2x up here into my quotient, 2x times the 3 has created this 6x. I've made it all the x squareds I need. I've made the x's that I need. This 9 here is the remainder. So two different ways you can write this out as an equation. If you remember, like, let's say I said 11 divided by 5. Hopefully you would say it's 2 with like a remainder of 1. So that could be shown as 2 times 5 plus 1 equals the 11. That's one way to do it. So in our problem, how would that one be written out? That would be written out as the x plus 3 times the quantity x squared plus 2x equals, or plus your remainder. We still need our remainder added on, equals the original pink x cubed plus 5x squared plus 6x plus 9. So if I multiplied this all out, I'd have my x cubed, I'd have a 3 and a 2x squared for my 5x squared, I'd have my 6x, but I would still need 9 to equal that original problem. As a dividing problem, if our original statement here was written out, do you remember what you write there is 11 divided by 5 equals 2, and then what do you do with the 1? And 1/5 left over. So this 1 was the remainder divided here by the divisor, the 5. So how would that look for our problem? It would look like the x cubed plus 5x squared plus 6x plus 9 divided by my divisor x plus 3 equals, for my answer, the x squared plus 2x plus, what was my remainder? 9 divided by my divisor x plus 3. So there's two different ways, if you're writing it as a division problem or if you're writing it out as a multiplication problem. So either way, I'll look over here, this page will have it all written for you in their notation with the two forms of writing it out as a division problem on the left, a fraction that's like saying the numerator divided by the denominator, or writing it out as a product of the quotient and divisor where you add the remainder. So either one of those methods for writing out the final equation of what we were solving would be acceptable. So let's just do another practice problem if we're supposed to divide this problem out. Just to see, so my divisor is 2x plus 3. And my polynomial that I'm trying to divide it into, 8x cubed. I have no x squareds. I have no x's. Just like, how normally if we'd have taken 5 or 7 into 2001, we have these zeros to hold these spots for these places. We're going to leave zeros to hold the spots for each degree of our polynomial. So here we go. 2x times what is 8x cubed? And I hope you say 4x squared. 4x squared times the 2x, 8x cubed. 4x squared times the 3, 12x squared. Write it under its like term. I needed what was in blue. At this point, I've created what's in yellow. So these cubes are good. I made exactly what I need. I made 12 positives, though, that I didn't need any. So if I'm subtracting or taking those away, what I really need now are 12 negative x squareds to wipe these out that I created. So you can think of it as adding or subtracting. If I want to add the opposite of 12x squared down, I would have negative 12x squared. I don't need any x's yet, but I still have that 27 that I also need. Continuing from there then. Take this little guy out of here from that last step. 2x times what will give me my negative 12x squared, and I would say negative 6x. Now multiply it times each part. Negative 6x times 2x, negative 12x squared. We made exactly what we needed of that leading term. And then negative 6x times 3, that's a negative 18x. So that's what I've now created. It's like you're subtracting that away. So if I'm subtracting away, I like to add instead of subtract, so I'm going to add the opposites here. I had negative 12x. I made 12 positive basically here now by subtracting away. So I made what I needed. Those are gone. That's good. That's what you should always have happen. Now I still need 18x because really in the last step I made 18 negative x's, but this is what I need to cancel them out. So now, get this out of here. This is a little confusing from that example. So now what do I need? Now I need to erase these extra lines from the last step again. Um, 2x times what to make 18x? Then I would say that's a 9. So if I take this 9 times the 2x makes my 18x that I need. And then 9 times this 3 makes 27. So when I take those away, it's all gone, and I've got a remainder of 0. So there's long division where it actually came out just perfect. The equation I would write here, 2x plus 3, this is the product form, times the 4x squared minus 6x plus 9 equals my original 8x cubed plus 27. Or, if I want to write it out in the quotient form, the 8x cubed plus 27 divided by, or if you like the fraction, the 2x plus 3 equals my quotient that it came out to exactly of 4x squared minus 6x plus 9. All right. So that original, that should have worked out that way because I believe that was a sum of 2 cubes, because 8x cubed is 2x to the third plus 27, which is 3 to the third. So sum of 2 cubes from the last lesson. And if you wanted to see how they worked it out and wrote it, here's an example. Should be the exact same thing that we just did on the last page. Leave it there for just a moment in case somebody is looking through that. Okay, let's move on then. You can pause it on that screen if you needed to. We're going to move on to something now that's called synthetic division. It's really like we're doing the same thing, but somebody came up with this algorithm that makes it all look a lot faster and easier, even though it may not. It really works best when this term right here with x does not have a coefficient. For sure when this is linear. If you have a quadratic, there's a method, but it's really pretty gross. So it's really nice if it's like x minus 3, because what you first do is you say, when does x minus 3 equal 0? And hopefully you say when x is 3. That's what goes out here in front. Now you pick off your coefficients. Notice there is no x term. So you have a 2, a negative 7, keep a 0 for the x linear term, and this negative 4. And so those go down next to negative 7, 0, negative 4. And here's how it sets up. It's really nice. Leave a space between here because we're going to write some numbers underneath each of these numbers. So it goes, draw a line, leave a space there. Here's how it starts off after that. The leading term comes straight down. You don't write anything under that one. You will after this. Multiply these two, and that product goes under the next number. And then add straight down. Then you do it again. Multiply these two, put it up under the next number, and then add straight down. One more time and we'll be done. Multiply these two, get that off from there, and add straight down. All right, this number on the end is your remainder. The next number over is your plain number, and then our variable was x, so there's an x here and an x squared, so our answer is 2x squared minus x minus 3 with, if you're writing it as the 13 over the x minus 3, that's fine for your quotient, or if you're writing it as the plus a remainder of 13, whichever method you're writing it, refer back to those previous slides, depending on what they're asking for in the problem. So here's the, again, so that you have an example. Is this the problem we just did? 2x cubed. Why do I feel like we got a different answer? or it's not finished. I don't know if they finished the whole problem. They're kind of showing you how it works and why it works in their steps for this synthetic division. If you come up with a remainder of 0, what does that mean? Well, when the remainder is 0, that means it's exactly divisible. So if I said 10 divided by 5, you'd say it equals 2, right? So is there a remainder in that? So what the remainder is 0. If the remainder is 0, then 2 is a factor, or 5 is a factor. And so that's what they're going to do on this next part, is say the remainder theorem. So if you divide it out, get a remainder of 0, then the original number you were dividing by, the divisor, was indeed a factor of that polynomial. So that's what this is saying. We learned how to use synthetic division there on that last example. Use synthetic division to help see if it's a factor of the problem. If it is, great. If it's not, well, we can rule it out in terms of trying to factor. So use the remainder theorem to evaluate. The population of tortoises on the island is represented by that polynomial. X is the year since 2015. Use the remainder theorem to estimate the population for 2023. Well, first of all, 2023, for the population, if you are going to do your 2023, how many years is that? 2023, how many years after, what did it say, after 2015? So is that not 8? So then we're going to go, and as you see that they did, take that 8, take the coefficients from your polynomial that models the population of tortoises. Use your synthetic division. Bring down the -1. Multiply 8 times -1, -8. Add straight down. Multiply 8 times -2, -16. Add straight down. Multiply 8 times -4, -32. Get 293. So the population for the tortoises in 2023 would be the 293. So how can you use the remainder theorem to factor and factor theorems to see if it's a factor? So they're wondering in this problem, for this polynomial, is the x minus 6 a factor? So what did they do? When does this equal 0? When x is 6, right? That's what goes out here in front. Pull all your coefficients off, 1, -8, 16, -23, -6. If we get a remainder of 0, then it's a factor. So that's the remainder theorem and using the factor theorems. So bring your 1 down, 6, bring it up, add, multiply 6 times -2, -12, add straight down. 6 times 4, 24, add straight down. 6 times 1 is 6, add straight down. Since the remainder is 0, then it is a factor. So then what's the other part? So we have the x minus 6, and then this is your number. These are your x's, these are your x squareds, and these are your x cubed. So if you take this right here times the x minus 6, that would equal the product, or their product would equal this original polynomial. Second part, try one more time. Is x plus 3 a factor of this polynomial? Is x plus 3 a factor? So when does x plus 3 equal 0? Hopefully you say at -3. That's what goes out here. Coefficients, 1. Skip the x to the fourths. No x to the fourths. So there's a 0 for them. The -5, the 9, the -1, the 3, and then take it away. Bring the first leading coefficient down. Multiply, add. Multiply, add. Multiply, add. Multiply, -3, -3, 9, add. Multiply -3 times 8, -24, add. Is the remainder 0? No. So then x plus 3 is not a factor of the original polynomial that's boxed in blue at the top. Okay, so using synthetic to check to see if it's a factor. And that's the last example that we have. And long division, synthetic division to help find factors of polynomials.